So thanks for staying for my presentation. So as it was mentioned, I will focus on common criteria in the context of our product, which is a real-time operating system that is designed by SYSGO. So what I would like to go through with you is to talk a little bit but quickly about the history of SYSGO around security, give you a quick landscape description about security and safety certification, because the two these days are tied together. More and more customers ask us to provide a solution that addresses both safety and security together. I will give you a quick overview on common criteria and how it is applied to PikeOS, so our RTOS. And also I will discuss about other market-specific or industry-specific cybersecurity standards and how they compare and map to common criteria. And to finish, I will illustrate that with a simple use case around the security gateway and describe what is our approach to leverage our common criteria certificate on our RTOS and how it does help our customer to more easily certify their entire system or equipment using common criteria or some other standards. SYSGO was created about 30 years ago, a little bit more than 30 years ago. For the last 20 years, we focused a lot on safety through our real-time operating system and on hardware real-time behavior also. But security was always in the back of our minds, so the design of our RTOS was also made in a way that security could also be achieved through the mechanism that we also use for safety. But lately, in the last 10 years, due to market demand and also because our solution can address cybersecurity requirements, we have also made a lot of effort in adding some functionality to our operating system, and we use a common criteria in order to demonstrate cybersecurity certification for the operating system. So we even participated to some work with Intel on some Spectre and Meltdown flow remediation, for instance. So what kind of benefits PikeOS, our real-time operating system, brings concerning security? I mean, first, the architecture is based on a separation kernel. So we use quite a few of the basic security principles to design the operating system, like principle of least privileges, the fact that the code base of the operating system is fairly compact and small, so we reduce as much as possible the attack surfaces. And we use actually the same product to address safety and security. There is no optional components or anything like that. The functionality that we focus on for addressing security are strict separation, so robust partitioning built on top of this separation kernel architecture. We all, of course, provide control information flow and control of the access to the resources that the operating system manages, which could be memory, cores, device driver, file descriptor, etc. And of course, we also take care of ensuring that the availability of these resources is being addressed. Concerning the cybersecurity standards, of course, the common criteria standard is recognized internationally. So as a generic standard, you have also additional generic standards like ISO 27000 that is more focusing on corporate, or other standards like FIPS, more related to IT devices and equipment. Then in the recent years, each industry has been creating their own cybersecurity standards that applies more to their market specifics. Of course, you have the avionic security standard, DO356, the automotive one, the ISO 21434, and the industrial automation standard, the 62443, which is also used quite often in the railway industry. So these standards have been used already in several projects. The avionics one is maybe a bit more recent. But what we see these days, at least for us, is increased demand in combining security and safety. Because we need to combine safety and security, you have also the pendant on the safety standards. So I'm not going to go through the whole list, but you have the also equivalent industry-specific standard for safety, whether it is for avionics, for the space domain, the automotive, the railway, and the medical. So we address also all these in addition to cybersecurity evaluation. Quick overview of common criteria standards. So it's divided in three parts. The first part is simply an introduction and description of the main concepts, like the security model and the security evaluation model. It also provides the concepts. The second part goes through, gives a list or a catalog, I should say, of security functional components that you can pick from and describe your own security functional requirement that applies to your particular device. The third part is around security assurance components. So it's also a catalog of security assurance requirement that you can pick from in order to describe your security objective and the way the evaluation will be conducted. For instance, in the common criteria standards, you have a security model. So, the owners of the device place value on the assets. And of course, they are responsible to protect these assets from threats or from hackers. So countermeasures need to be put in place in order to lower the risks for these assets to be compromised by the threats coming from external agents or simply also users that are not necessarily malicious but don't use a product as expected. On the other side, for the evaluation, so the demonstration that the security claim in the product are correct and have been properly implemented, you follow a certain model as well that is described in the standard. So the evaluation methodology is there to provide the right level of confidence for the owner of the device or the user of the devices that all of the mechanisms, the countermeasures that have been put in place to reduce the risks and in a correct manner for the assets to be protected, all this methodology will allow you to demonstrate that. So the common criteria in part 2, which is about the security functional requirements, it's organized in several classes, and each class is subdivided into families. So you have a common type of functional requirements around, for instance, security audits, around cryptographic support, around privacy, availability and utilization of resources, etc. So when you define the security claim or the security requirement of your devices, you basically pick from some of these classes. You don't have to address all of these classes. It depends what your device is used, but it gives you a common framework to be able to describe the security objectives for your particular device, and it makes it easier to compare devices of the same class between each other. The same thing is true for the security assurance requirements. So these are a list of classes which cover the whole life cycle of your device. So from conceptions to implementation, testing, deployment, so the operational phase, until the device is decommissioned. So each of these classes also will be subdivided into families of requirements that will help you to define and describe all the steps that you'll have to take in order to demonstrate that your security claim are correct and have been properly implemented. So all this will give you a sufficient level of confidence to the user. So for instance, if we look at the evaluation assurance requirements, you see that they are organized in different families and subfamilies, and there is also a concept of assurance level. For common criteria, it goes from EAL 1 to EAL 7. The higher the number is, the more thorough and the more precise will be the activity done during the evaluation process of your system or of your device. So initially for PikeOS, our RTOS, we targeted EAL 3, which is a medium level, just to gain experience in how the process will go. And recently we have achieved with the latest version of PikeOS EAL 5+, and I'll give you a little bit more details about that, which is a fairly high level of security assurance for a full feature RTOS. And we'll see actually that we go beyond EAL 5. So if you look basically on each column, you will see that for each class of requirements, you have a number, and the higher the number is, the more thorough or the more complex, the more costly also, unfortunately, the processes and the activity you need to do for demonstrating the security claim will be. The common criteria standards also require for a precise documentation. So there is a concept of a security target document. This is the main document that you will craft in order to describe the security objective of your device, the type of security functional requirements that are being implemented to satisfy your security objectives, as well as the list of security assurance requirements that you will use in order to demonstrate that this claims is true. So the theory is the target of evaluation. It's basically the product, your security element, your security product, for which you need to demonstrate that your security functionality, your security claim are correct. So it's also structured in a very precise manner. Again, the main purpose is to be able to compare different devices from the same class. So if we apply that to PikeOS, our real-time operating system, the choice we made for common criteria, it's because first it's an internationally recognized standard. And moreover, it's a generic. So we didn't want to choose industry-specific standard simply because we have to address different industry, different markets. And we'll see later, most of these industry standards actually share a lot of commonality. And we did actually some mappings or compliance matrix, if you prefer, between common criteria and the other industry-specific standards. So we choose to focus on common criteria in order to be able to apply that to the different industry-specific standards when required. In our particular case, we use the BSI, the German BSI, so the German Federal Agency for Information Security. And so there is also a requirement for testing of the device to be done in an independent manner. So it's not SYSGO that does all of the testing, but instead we rely on accredited independent test laboratory, so in this case ATSEC in Germany, to perform all of the validation and testing activity that BSI review and issue a certificate or not, depending the result of this testing. So we got the certificate. So the type of security requirement that we have certified with PikeOS, it's in order to give you a partition operating system that will help you to create a secure architecture for your actual device. So strict separation in the spatial and time domain is one of the most important components of the operating system, and it's one of the security functionality that is being evaluated. But there are also, of course, functions around access control of the resources, guarantee the availability of the resources. I mean, classic requirement that will be around confidentiality, availability of your assets. So we also make sure that there is no residual information that is being left when partitions communicate between each other. So this gives you an execution platform that will help you to define a software architecture that is resilient to threats and to attack. Of course, I mean, you may add additional security functionality like cryptography that are not necessarily handled by PikeOS by default or not included in the scope of the evaluation. But our goal is to give you a secure foundation for a robust software architecture on which you can base your design. And as you can see, we didn't include all of the security functional classes in the way we have described, but we have focused, for instance, on the protection of user data, identification, notification of requirements, and security management and resource utilization. So when you define a security target with common criteria, you are not forced to pick requirements from every class. You just adapt it to your particular device. So in the case of EAL5+, normally we should have stopped in the column that is titled EAL5. But because we also want to address some specific French markets where there is a requirement for the ANSI, so the equivalent of the BSI for Germany, rely also on common criteria but added, I guess, a French touch. They call the level of evaluation for something equivalent to EAL5, qualification renforcée. And these require evaluation that goes beyond EAL5. And that's why you see that for certain security assurance classes, we went beyond EAL5, and in particular for the vulnerability analysis. And this is important because that means we basically spend quite a lot of time making in-depth analysis of what are the threats or the vulnerability in the hardware and in the software to address these. So I talked about common criteria so far, which is a generic cybersecurity standard. But of course, when we address a solution for avionics, for automotive, our customers are asking for compliance to industry-specific requirements. So what we did is that with the experience we gained using common criteria as a foundation for our security demonstration, we did some compliance analysis to establish some compliance metrics between these standards. And what we have found out in this particular case, for the avionics standard, security standard, the industrial one and the automotive, that most of the security assurance requirements map directly to common criteria requirements for the bulk of them. There are just a few that are only partially compliant, so that would require some additional activity if we need to be compliant to either avionics, automotive, or industrial specific requirements. There is also a set of requirements that are not applicable for the operating system, simply because for all of these are requirements that are addressed at the system level. So not really by the operating system, but by the end customer. Of course, we are there to support this, but this doesn't really apply in the context of a component of a system, and this component being the operating system. We also see commonality in the way the security model or the evaluation model are defined in these different standards. So for instance, here, if we take the common criteria standard and the automotive one, we see equivalence in the concepts. So we talked about owner for cybersecurity, we talk about items, and functions and components in automotive. while for the assets they are described in a similar way, and same for the other concepts as well, threats, risks, as well as countermeasures find their equivalent also in the automotive standards. And the same is true for the avionic and other standards. Same is true for the security life cycle. All of these standards address the whole life cycle of the product, from conception to decommissioning. These standards also are based on a top-down strategy for the analysis of the threats, the definition of the assets, and also the definition of the vector of the threats. So you start from the systems and you decline all of the description of all of these elements for the subcomponents of your product. This is common for all of these standards. So here we take as an example, I believe it's automotive and avionic. They all have this same top-down strategy, at least for the threats analysis and risk management. So when we introduce PikeOS in this, you can basically base your architecture on the proven properties, security properties of PikeOS. And this will allow you to have, at least for the security requirement, a bottom-up approach. So knowing the functionality, the security functionality that the operating system provides, you can base your architecture and your security requirements on these claims. So you won't have to demonstrate, for instance, that there is no data leakage between partitions, between application executing in separate application. You will be able to rely on the robust partitioning, so the isolation of the different software components that your system is architected around. And maybe to illustrate that a little bit, we can take the example of a secure gateway, a very simple one, which consists of two networks. So data has to go from network A to network B and go through a filter which authorizes only specific traffic to go through according to some filtering rules. And there is also, of course, some logging information that is being recorded. So in this particular simple use cases, of course, we can define assets as well in the sense of common criteria, but also for other standards. So the assets that have to be protected will be, for instance, the filtering rules. You should not modify them, otherwise, of course, you can expect that unexpected data will be routed through to the network B. You have to protect the data that is being logged. You have to protect the software that is implementing your product, and you have also to protect the data that is being transferred from network A to network B. So you also define your threat agent, which could be a user with malicious intention, or a user that, for instance, that gain physiological access to the gateway. The threats could be, possible leakage of data, illegal configuration if the filtering rules are being modified, and also malicious corruption of the data being logged. In order to define, to implement in a robust and secure manner this kind of firewall, if you prefer, or data diode, you can use the characteristic of a partition operating system like PikeOS to isolate the different functionality and also to provide multiple layers of protection to your assets. So as an example, we can imagine that each network will be managed in a different containers, whether it's for the Ethernet driver or the network stack. The filter, of course, which is a critical part of the system, will be isolated in its own partition. So even if an intruder can gain access to the partition that manage the traffic, it will not be able to go through the separation mechanism provided by the RTOS to gain access to the filter. Same for the filtering configuration, the filtering rules, and the logging data. So you can basically rely on the security mechanism and characteristic of the operating system to define an architecture that is resilient to threats and to attacks, and you won't have to demonstrate that the security feature, so robust partitioning, safe communications between application or partition, are guaranteed. You can rely on the claim that we have demonstrated through common criteria. But what is important to understand here is that each of these industry-specific standards have a concept of environment in which your security device or your security equipment is operated, and assumption around that environment. So this is typically called the security context or the security environment in which your device will be operated. And in the case of an operating system that has already been certified given cybersecurity standard, you can basically use that component, which basically is your execution platform, as an out-of-context component. You will not include it into your system-wide security evaluation, since you can rely on the fact that the assumption that you made around the environment, which could be, for instance, the execution platform or the RTOS, provide for robust partitioning, provides for secure communication mechanism, provide for additional functionality to ensure confidentiality, for instance. You can rely on this and take these assumptions, meaning that your demonstration will basically focus on your application, which are used to implement your security requirements, but you won't have to go down into the operating system. You won't have to demonstrate that because you can rely already on a certificate for that. So what it means in the end, that you can split your security evaluation activity into two components. The system or equipment level demonstration that will focus on the application that you as a user of the RTOS are implementing for your security measures. And then you can rely for the platform level, so the execution platform, the RTOS, in this case, for instance, PikeOS, you can rely on the evaluation that has already been done using common criteria, and you won't have to include that into your analysis. There might be some small activity that may need to be added to what we did for common criteria for PikeOS to address, for instance, the partially compliant requirement if we need to do it for instance, an automotive or avionic cybersecurity standard. So in the end, the fact that you can rely on this EAL5+ Common Criteria certificate for the RTOS like PikeOS will reduce in a significant manner the effort you'll have to do to certify your overall system, because you will simply focus on the application you develop, not on the execution platform. Thank you.